In this video, we're going to continue to talk about Chapter 2, and we're going to move from variable types to graphical summaries. Now you're going to need to remember those variable types because they have consequences on what types of graphs that you can make, okay, or charts or plots, all right? So we're going to first talk about graphical summaries for categorical data, okay? So when you have categories, you have a fixed set of finite things, okay? It really limits the number of graphical summaries that you can make about that variable, right? The three most popular ones that we're going to talk about right now are the pie, bar, and Pareto charts. Okay, usually they're called charts for categorical variables. Whenever I refer to one of these graphical summaries, I'll usually call it a plot. Okay, many people will call them a graph, but in mathematics, a graph has a very specific meaning. Okay. So there's a mathematical definition for what a graph is, and some of these don't meet what a graph is. So I'm going to call them plots. All right? Feel free to call them graphs, but I just can't, for my own sanity, call them that. That was, sorry, about the side note. First, let's talk about a pie chart. Okay? A pie chart is probably one of the most popular things, popular graphical summaries that people use. Okay? And you'll see the pie chart on the left where each category is listed, okay? And then it's all put together in a pie shape thing. So it's in a circle where each variable gets a certain percentage of that circle, okay? And the percentage of the circle corresponds to the percentage of that category in the variable. Okay, so here 30%, maybe 30% of people said they like bananas the most. That's their favorite fruit. 27% of people said grapes. 20% of people said pineapples, so on and so forth. Okay, pie charts are very popular. But in the statistical community, pie charts do not have a very good reputation. And there are some fairly good reasons why that's true. Okay? The biggest is that people cannot see in what's called polar coordinates well. Okay? So visually, you can look at maybe a bar chart or a Pareto chart. They're the other two on here, okay? And you can tell differences in heights of bars very well, okay? Humans can tell that easily. So if you look at the bar chart, which is the bottom middle chart on this thing, you can see very clearly that a premium is slightly taller than very good, okay? So you can definitely tell the differences there. But if you went over and looked at that pie chart and I took away the percentages, okay, the percentages being there make it an okay chart. But if I took away those percentages and I told you to say which is larger, grapes or bananas, you're probably going to have to think about it a little bit, okay? Look at it very closely, and then maybe you can say banana, okay? Also, when you get a bunch of variables. So here it's nice I only have 5 of them, but what if I had 20 different categories? So I'm sorry, not variables, categories. If I had 20 categories, it's going to be hard to fit them all into a pie chart. Okay? So those are the reasons why pie charts are generally frowned upon, okay? In the statistical community. People outside make them all the time. But I just have to give you that sort of warning and precursor. The second one, and the one that I recommend that you use whenever you see a categorical variable, is a bar chart. Okay, a bar chart. A bar chart, as you may know or can see very clearly here, it lists each category out, okay, in the categorical variable, and then the height of the bar corresponds to how many instances you see in the data. Okay, so here's a variable. The variable is cut in the bottom. Okay, it has 5 categories, and so you can see the heights of those bars represent how many diamonds in the data set were ideal, premium, very good, good, and fair. Okay. Luckily for the diamonds, it looks like there are a lot of ideal cut diamonds, okay, and not a lot of badly cut diamonds. So that's a bar chart, I think pretty self-explanatory. The last chart is a Pareto chart, okay? And a Pareto chart is simply a bar chart where the leftmost bar is the highest, okay? So if you look at the chart on the right, the market share of operating systems for smartphones in 2013, you'll see that the bars go in descending order. Okay, the bars go in descending order. That is a Pareto chart. Simply a bar chart where the bars are ordered, okay, from highest to lowest. So those are graphical summaries for categorical data. For quantitative data, there's a lot more options. We're only going to talk about a few here, but there are a lot more. The most common are a dot plot, a stem and leaf plot, and a histogram. Okay, so you've probably seen a stem and leaf plot and a histogram before, maybe a dot plot. We'll talk about 2 out of the 3 here. A dot plot, okay, shown on the left, places a dot at every instance of a quantitative data point. Okay, so every time on the left, this is a graph of displacement for engines in different cars. Okay, and so every engine that has a displacement of 5.4, okay, you'll see a point at 5.4. Okay, and so you'll see as they increase, you can tell by the heights of the dots where the different data lie most often. Okay, dot plots are great when you have not a lot of data. Okay, when you get a lot of data, there's a lot of dots, and that can be very overwhelming. And also, it's great for discrete data. Okay, so if you imagine if I put a dot at every point where a continuous variable happens, in a continuous variable, it's not very likely that I see the exact same point every time. What you'll get is a very wide spread of dots, okay, but no height. And so that's not going to be very helpful to us. So a dot plot is great for not a lot of data and discrete data. A stem and leaf plot we're not going to talk about, okay? I'm sure you did in high school or in middle school, but we're going to skip over the stem and leaf plot and go into a histogram. A histogram is the most popular plot for quantitative data. In a histogram, it bends, so I have a quantitative variable, maybe continuous, okay? And so like I said with a dot plot, if I have a continuous variable and I put a dot at each point, all I'm going to get is a long list of places where this only happened once. In a histogram, what happens is it bends. So in making a histogram, you take the range of possible values of the variable, and then you create a binning system where you break up the range into a finite number of bins. Then you count how many instances of each thing, of each range, of each bin that happens, and then the height of that bin is the height of the box here. Okay, so how many instances happened between that range is where the box goes. And so you can see in the picture on the right, okay, that's what a histogram looks like. Hopefully that's fairly self-explanatory. And I think we've all seen these in some way, shape, or form before. Now, that's going to be the end of this video. When we come back, I'll describe quantitative data. Okay? We can't really describe categorical data, but we can describe quantitative data.